So first of all, let me give you some definition of the different devices that we have on the network. The devices that we have are based on the layer that we work with. So we have layer one, which is the physical layer. You know about that. And the device that we have here is hub. Like I said, hub is a transparent device. It doesn't understand anything other than providing more links so that other computers can connect to your network. And maybe some of the hubs have kind of a repeater or some amplifying devices inside so that the signals that go through the hub come a little stronger on the other side of the hub. One problem about the hub is this. When you have a hub, as a matter of fact, what it provides you is kind of a virtual wire like this. And every computer is connected to that virtual wire. As a matter of fact, you have something like this on your network. And based on my experience and a lot of other network administrators, when you have more than 10 devices, things are going to start to become a little weird. Some of the computers are not visible anymore. Some of them come and go from time to time. The connection is kind of intermittent. So when you have something like a hub, as a matter of fact, you should not go over 10 devices on that network. And that is based on my experience, of course, but you can just try to see if the hub that you have supports something like more than 10 devices. What you have here is a layer one connection. More than 10 devices is not so favorable. What you have here is a half duplex network. This means that each device can either listen to or can talk. Let's say that computer one wants to send some information to one of these other computers. So computer one is going to initiate the communication. It is going to put some electrical signals on the wire. Now, this wire sends the signal in both ends. It doesn't matter which side. Both directions are going to receive the signal. So the signal is going to be sent to other computers. They are going to listen to and they are going to pick up the messages that are sent using those signals. Now, let's say that computer 2 wants to send some information at the same time as computer 1. So what happens? There is going to be a signal collision. And we call it exactly this. We call it collision. That's senders are going to be destroyed. So this means that computers cannot understand what we have here. And based on that, computers need to resend the information again. If it is, for example, a TCP connection, then they need to resend the information again because the other computers cannot understand what was on the wire. And based on that, again, what computers do is they reduce the speed of communication. So this is going to be another problem that we are going to face during this kind of communication. And say that we have lots of computers on the same wire, that's going to even reduce the speed to something like even 5% of the original speed that we can have. I mean, if the wire supports something like 10 megabits per second, you cannot go over something like 100, 200 kilobits per second because of this problem. So what we do is we use a kind of a process that is called collision detection. So we have something that is called carrier sense. And this means that before we send signals on the wire, we need to make sure that the wire is empty. No signal is on the wire, and we can safely go ahead and send the signals. This is called carrier sense, the first part. And then we have the second part, which is called multi-access, which means that now that I know the wire is free from signal, I can send it. And as soon as I have sent, just wait for the others to use this carrier so that this is not just congested by me. So CSMA is this. And after that, there is another thing that is added, and that is called collision detection. So three different processes that each one of them is important. So whenever computer one wants to put some bits on the wire, the first thing that it does is it listens to the wire and it makes sure that the wire is free from signals. There is no problem on the wire. There is no problem sending the signals. And as soon as it understands that the wire is empty, it starts putting the signals on the wire. Now, if computer 2 wants to start communication, it does the same thing. It listens to the wire and it sees that some signals are coming and going on wire, so it just waits for some free window so that it can start communicating. If wire is not empty, computer 2 is not going to start communication. Now, the problem arises when both of these computers start to send information at the same time. So what happens? There are some rules for that. The first thing is this. Each computer has a network interface card. And I say computer, it doesn't really matter if it is a computer or a network interface card on any other device, whether it is router, switch, computer, whatever it is. And it has the network interface card. Let's say this is this, and it is connected to the wire. And this network interface card has something like a loopback inside, and whatever it sends on wire, it just sends it on the loopback. This loopback is kind of error detection mechanism for it. So whenever it does send some signals on wire, it just listens back again. And because signals go and come again, this network interface card can listen to what it has sent on the wire. And when it receives its own signal, it just compares it with what it has put on this loopback inside it. And if both of them are the same, then the network interface card will know that there was no problem. But if they were different, then this network interface card would know that there has been a problem, and most of the time this problem is a collision. Now that there is a collision, this means that two devices or more devices have decided to send information at the same time. What happens? This NIC or network interface card decides waiting time. This waiting time is a random time. So let's say that it decides to wait for something like 20 milliseconds or maybe 70 milliseconds. I don't know. That is something chosen by random. The other device for sure has detected the collision, and it starts another random timeout or waiting time. Let's say for this is going to be 30 milliseconds. Very rarely, both of these computers have the same random number. This is not, this doesn't happen so much. But let's say the first one has decided to wait 20 milliseconds, the second one has decided to wait 30 milliseconds. And when the first computer's timeout has expired, it starts again to send the information. It starts again sensing the carrier, checking to see if it is signal free, and it starts sending the information. And if again there is a collision, it is going to go to this process, wait again for some random number of milliseconds, and after that again it starts sending the information on the wire. So this way computers decide, or let's say that devices decide to avoid the collision and make sure that there is no problem on the wire. So like I said, if you have more than a certain number of devices on the same wire, it is going to reduce the quality and the speed of communication dramatically. So you just prefer to go with some better device. And that better device can understand these kind of things. First of all, it doesn't put all the devices in the same broadcast domain, in the same collision domain, as a matter of fact. And collision domain is something else that I forgot to tell you. Whenever we have something like this, that collision can happen on that. This is called the collision domain. So here, our domain is this wire, and there are 4 computers connected to that. So these 4 computers are on the same collision domain. But when we reduce the number of devices on this collision domain, the quality and the speed of the connection is going to increase. So one way to do that is to go with layer 2 devices.